Hi everyone! Today I want to demonstrate a practical geometry checking using a DICOM RTPLAN file. Specifically, I'm going to show how to determine whether a dose specification point or DSP point is blocked by jaws or multi-leaf collimators, evaluated per control point and directly from the RTPLAN DICOM file. Why this matters? In most clinical workflows, we visually inspect apertures in the treatment planning system and trust that the dose point is properly exposed. But once you start looking at the dynamic delivery with rotating gantry angles, moving jaws and MLCs, changing at every control point, it becomes much harder to reason about this accurately by eye. The goal here is to answer a very concrete question. At this specific control point, is the dose point geometrically open or blocked? The key idea is to reduce everything to geometry in beam's eye view. At each control point, I do 4 things. First, I take the dose specific point and project it into beam's eye view coordinates at isocenter. Second, I gauge that point against the Y jaws. If the point is outside the jaw opening, we can stop immediately. It's outside the field. Third, if it's inside the Y jaws, I determine which MLC leaf pair corresponds to that Y position, using the leaf position boundaries from the RTPLAN. And finally, I check whether the point lies inside or outside the leaf opening for that specific leaf pair. Let's go over some details. First is projection the DSP point to the beam's eye view. Here are the rotation matrix, and here is the function to project the DSP to the beam's eye view. Here, I'm not relying on patient axis, machine axis, or any vendor-specific conventions. Everything, the dose point, the jaws, and the MLC leaf positions is evaluated in the same beam's eye view coordinate system. Once you do that, the problem becomes purely geometric. So for each control point, we take into account the gantry angle, the couch angle, and the collimator angle, and to project that point to the beam's eye view. And here are a few functions to get the DSP point coordinates. It can live in multiple places, and we are making it robust so it's able to find the DSP point coordinates. In terms of the jaw checking, from the RTPLAN, each control point contains the jaw positions. After projecting the dose point into beam's eye view, I compare its span coordinate against the Y jaw limits. If the point falls outside the jaw opening, the result is immediately classified as outside the field. And here is the functions related to get the jaw positions for each control point. Next, we move on to MLC leaf pairs. If the point is inside the jaws, the next step is identifying the correct MLC leaf pair. This is done using the leaf position boundaries, also defined in the RTPLAN DICOM file. Those boundaries define the y extent of each leaf pair. So once we know the BV-y coordinate of the dose point, we can directly determine which leaf pair is relevant for that control point. This automatically handles different leaf widths. So here are the functions to determine which leaf pair correspond to the DSP point coordinate in the beam's eye view coordinate systems. This code also lets you put in the control points that you want to debug to double check your geometry. And it also will tell you the weighted MU fraction of that point is blocked by the JAWS or MLCs. Now let's run it. I have an RTPLAN file, and we print the first control point as a debug, but you can also put in a number of control points here so that it will print out the information for your checking your geometry. And it print out the gantry angle, the collimator angle, the couch angle, and it will tell you the beam's eye view of the DSP point for this control point. And because it is within the jaw limit, and then it will compute the leaf index for that DSP point at that Y position. And then further, by comparing with the two leaf positions, it determines whether the point is blocked by the MLC or not. So this method is robust because it doesn't rely on display conventions or naming conventions. As long as the RTPLAN is valid and the geometry is consistent, the result follows directly from the physics of beam delivery. Everything is evaluated exactly as it would be delivered by the machine, control point by control point. So this also output for each beam the DSP coordinate system and the number of points blocked. It also tells you the specific control point that is blocked. Additionally, it also tells you the MU weighted block fraction. The main takeaway is this: if you transform everything into beam's eye view and let geometry decide, jaw and MLC blocking checks become straightforward and reliable. This kind of logic can be useful for independent plan verification, automation QA checks, or simply for better understanding what a dynamic plan is actually doing at every delivery time. Thanks for watching. If you found this helpful, feel free to like or subscribe, and I'll continue sharing practical DICOM-based physics checks like this. Run this script and let me know what results you find out. And if you have any questions or comments, also feel free to let me know. See you in the next video. Bye.